Hello my dear young and energetic physiognomy. A very warm welcome to Diksha Vedantu English 9th and 10th. I am your master teacher Neha ma'am, and in today's session we are going to discuss about the chapter Light in just 30 minutes. This video is specially when you are hurried to revise all the things. Within 30 minutes we are going to revise the complete chapter including reflection and refraction. So in today's session, we'll be covering light chapter within 30 minutes. So let's start today's session without wasting much time. Before moving ahead, those who haven't subscribed the channel yet, just go and subscribe the channel. Hit the like button if you like this video and share the videos with your friends. Moving forward, let's start. What are the topics that are going to cover in this session? So we'll be studying about reflection, we'll be studying about image formation in plane mirror, ray diagrams, bimirror, bilens, refraction. All the concepts will be discussed in today's session, so don't worry about that. Let's start quickly with the reflection. What is reflection? Simple question, basic, and these kind of questions do not arise in the board examination also. So reflection is nothing but when you take a ball and hit it on a ground, it will just bounce back. Similarly, when a light ray falls on a plane, smooth surface, it gets reflected, it bounces back. That process is nothing but reflection. So how do you write it? The bouncing back of light rays from the object is called as reflection. Clear? So this is nothing but a simple definition. Moving forward, what is laws of reflection? The angle of incidence is equal to angle of reflection, first law. Second law, incident ray, reflected ray and the normal or lie in a same plane. Very basic concept which you have been studying from 8th standard, right? So I'm not spending here much time. If you want to see the video lectures in very detail, I have already done the sessions in the channel separately for reflection and refraction in very detail. You can go and check out that too. Yeah, let's move forward now. So one of the beautiful example for reflection is moon. We are able to see the moon because of the process of reflection. Right. Coming to the next important part, you may get 2-mark question stating, they may ask you what are the properties of image formed by plane mirror. So what are they? Just imagine yourself in front of a mirror and write down the answer. Always virtual and direct images are formed. The light rays do not actually meet. You cannot catch the image on the mirror. Hence, it's a virtual image and you see yourself upright, right? So, it is erect. Moving forward, size of image is same as size of object. Yes, of course, we can see that in the mirror. And also, distance is same. Image distance and object distance are same. If you move back, if you move away from the mirror, the image also moves away. If you come closer to the mirror, image also comes closer to the mirror, right? Image is laterally inverted. In this picture, you can see a boy wearing the t-shirt which has physics on it. But how it is appearing on the mirror? It is laterally inverted. Horizontally, it is inverted, not vertically. Clear? This is very simple, very easy. Let's move next. So here we have a main concept. So be aware of this concept. They may ask you what are the components of spherical mirrors for 6 marks, 5-mark question, or in the MCQ they may ask each one of them. So you should be prepared for both of them. Let's start. Before starting that, we should know that how mirrors are formed. Mirrors are formed out of a hollow spherical what I can say mirror, right? One hollow spherical shell will be taken, either outside or inside will be polished, right? And other side will be reflecting. A slice is taken out from that sphere. That slice is nothing but the mirror. Simple. Moving forward, center of curvature. Center of the sphere from which mirror is taken out. The sphere has one center, right? That center is nothing but center of curvature of the mirror. Okay. And sphere has the radius. That is radius of curvature of the mirror. How to write it? Radius of curvature is defined as the radius of sphere from which mirror is taken out. Aperture. Aperture is nothing but the entire reflecting surface is called as aperture. Pole. Pole is the midpoint of aperture. Simple. Principal axis, the parallel line that is passing through the center and pole is called as principal axis. Fine? Good with this? Done? Okay. Let's move forward then. What is focus? What is focal length? When parallel rays incident on a spherical mirror. So before that we should be knowing here about spherical mirrors, right? So what is concave mirror? Curved inward. I have explained that concave, cave-like structure. So concave is inward, inside surface is reflecting. When parallel rays incident on the surface, they after reflection, they meet at a same point. That point is called as focus. Yes, ma'am, understood how to write it in the exam. The point on the principal axis where all the parallel rays actually meet, but for convex mirror, it appears to be meet after reflection. Concave mirror is a converging mirror. Convex mirror is a diverging mirror. Okay. So what is focal length? The distance between focus and the pole is called as focal length. You have the pole here, you have the focus here. The distance between them is focal length. Clear? Radius of curvature. Now there is a relation between this focal length and radius of curvature. By the image also you can see that if we double the focal length, we'll get radius of curvature. Hence you can say r is equal to 2f or f is equals to r by 2. This is important. For 1-2 mark, they may ask any numerical. So be aware of that. Focus is equals to r by 2, focal length, right? Let's move forward. Sign convention for reflection of spherical mirror. This runs same with the lens also. So it's important and it's very simple. No need to worry about these complications. Simple, just consider a graph of x-axis and y-axis. Positive x-axis, positive. Any distance you are measuring towards the right will be positive. If you are measuring away from the pole in the left side, it is negative. Upward, positive. Downward, negative. The origin of a mathematical graph is pole over here. And in the lens, it will be optic center. So I have made a detailed video about the ray diagrams in which I have explained this each and every concept in the detail. So yeah, it will be pinned in the comment or else in the description. Go do and check out it. So it's interesting. Moving forward, standard incident ray. There are 3 standard incident rays and very simple. Any ray that is coming parallel which strikes on the mirror after reflection, it passes through the focus. Any ray that is passing through the focus and it is incidenting after reflection, it passes parallelly. Simple. Another one point is center of curvature. The ray gets incident through the center of curvature. After reflection, it gets reflected back from the center of curvature. So I simply say it as focus, parallel. Parallel, focus, center of curvature, center of curvature. They'll not ask you directly about this, but you should know these terms to draw the ray diagrams. So what are the ray diagrams now? So we have 6 ray diagrams for concave mirror starting with object at infinity, right? So object when it is at infinity, rays come parallel and we have studied parallel focus. So image is formed at focus. It's small size, diminished, you can remember with the star. Star is very far and the image you can see is just point sized. Moving forward from the infinity, the object comes little near to the mirror. So that is beyond C. Okay. Again I am reminding you, I have explained this with the tricks to remember. So please do check that. And yeah, when the object is beyond C, the image is formed between C and F and the image size is little bit increased but it is diminished image. And the image formed here are real image because the rays are actually meeting. Moving forward, when the object is at center of curvature, image is also formed at center of curvature. And same size, same distance, these are the properties of third ray diagram of your concave mirror. Moving forward, when object is placed between center of curvature and focus, image is formed beyond 2f and now the size has been increased. It is an enlarged image. Again, when you take it forward between F and O, that is focus and the pole, the image is much more enlarged, but the image is formed at infinity because object is at focus, so image goes to infinity. Still more near, that was at F. Let me correct, that was when the object is at focus. Now when object is between focus and pole, we get a virtual image over here because the rays after reflection, they diverge, they do not meet. When we trace back the rays, they'll meet. So hence here at the last condition, we will be getting virtual image and the size is enlarged. Moving forward, convex mirror. Convex mirror is a diverging mirror. Hence you cannot find any real image over here. The images formed by convex mirror is always, it's always virtual. And virtual images are erect. And what else is the property here? It is point size diminished. Always the size of image will be small in convex mirror. Simple? Yeah. These are the points that are given in your textbook. Very easy to remember. I have explained this 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. With that strategy, you can remember this. Applications of spherical mirrors. Where do we use these spherical mirrors? So first of all, talking about concave mirror. Concave mirror are used in the torch, searchlight, vehicle headlight to see, right? We want the focused beam. Concave is nothing but Concave is nothing but converging mirror, right? Shaving mirrors, because image size is enlarged. Dentists use that to see the enlarged image. Solar furnace to get more rays at one point. Clear? Next is convex mirror. Convex mirror forms small sized image. So hence it is used in rarer view of vehicles to see whatever behind the vehicles are coming. To see that, we want a convex mirror. Then we have reflecting for street lights. In the street lights, we don't want the light at one region. It should cover the street, right? So we use the diverging lens over there. Next, security purposes, to cover entire area. Not a specific area, but entire area should be visible. I hope that's clear. Moving forward, what is magnification and mirror formula? Magnification is nothing but how big or how small the image is formed by the object. So magnification is the ratio of height of image by height of object. You can write m is equals to hi by ho, right? So that is equal to minus v by u. Remember this minus. I have a trick here, that is magnification m, mirror m gives you minus m. So you can remember with this trick. Coming towards mirror formula, as mirror is the first formula, right? After mirror formula, we are going to study about lens formula. So mirror formula is positive 1 by v plus 1 by u is equal to 1 by f. This is mirror formula. So you'll be solving many numericals over here. I have bought a separate session for numericals which you can check, and I'm bringing more numericals also. So till here we are done with reflection. Now let's enter to refraction. How does refraction occur? Right? So see here. When does the refraction occurs? Mainly it occurs when the light ray is changing its medium. It's moving from one medium to other medium. Only at that point, at that time, we can see refraction. Clear? So what are mediums? It may be air medium, water medium, glass medium, or different kinds of medium. Let's start. So what is refraction? What's the definition? The phenomenon of bending of light ray when it passes from one medium to other is called as refraction. What happens to the light when it passes from one medium to other medium? It will bend. So this is refraction. What are the laws of refraction? As we studied in reflection, here the incident ray, refracted ray, normal all lie in a same plane. But the second law is also called as Snell's law, and it states that sine of angle of incidence by sine of angle of refraction is equals to a constant. So remember this. Moving forward, refractive index. Many students have questions regarding refractive index. Let me cater that here. Refractive index is nothing but the ratio of speed of light in the given pair of mediums. So here we come across two types of refractive index. One is absolute refractive index, another one is relative refractive index. Absolute refractive index is nothing but we are comparing the speed of a light in a medium with air medium. Okay, so that will be equal to n is equal to speed of light in air by speed of light in the medium. But what about relative refractive index? In that we are comparing two different mediums. It may be any medium. We call it medium 1, medium 2. Refractive index of the medium will be equal to speed of light in medium 1 by speed of light in medium 2. That's all. Okay. And the important point to remember here is when the light travels from rarer medium to denser medium. Okay. What is rarer medium? The particles will be freely arranged like air. What is denser medium? Glass, water. You can refer, and it changes when the different pairs comes here into the picture. So when the light enters from rarer medium to denser medium, rarer medium is a free medium. It's coming around, say freely it's coming. But when it goes to the denser medium, it will try to move towards normal. So how much is the density? If the denser medium is very dense, so light will move more towards normal. I hope my words are clear. If you have any doubt, you can just put the comment in this video. I'll be answering to your doubts. Okay, don't worry about that. Medium, okay, when vice versa is nothing but when light ray moves from denser medium to rarer medium, it will move away from the normal. Right? So, image formation in spherical lens. So, before studying about image formation in spherical lens, let me tell you, we know that there are two types of lens. One is concave lens and another one is convex lens. Concave, let me correct, convex lens, right? Convex lens is a converging lens and concave lens is diverging lens. There is change between mirror and lens, so just remember that. Concave mirror is converging, concave lens is diverging, and the opposite for the convex, right? So convex lens is converging, right? So you come across 6 ray diagrams with the convex lens. We'll be studying about that. Before that, again here also we'll be checking with the standard incident rays, and that are same. So parallel, focus, focus, parallel. Instead of center of curvature, here we see the ray passing through optic center. Clear? That's the difference over here. Moving to the 6 ray diagrams, very similar with the concave mirror. Infinity, focus, beyond 2f, between f and 2f. But it is, you can see the diagrams, right? Here f1, f2, here f2, f2, 2f2. I hope that's clear, right? So these are the ray diagrams. Similar, very similar. No need to explain here again. 6 ray diagrams, fire forming real image, but the last one will be getting virtual image. So that is on your screen, right? So point size diminished and same size enlarged, highly enlarged. The size varies like this and it's very easy. Okay. Next, image formation in the spherical lens, that is concave lens. Concave lens is diverging lens. Hence, here you will be getting diminished, virtual, erect images. These are the properties. And where is the position? Infinity, focus, between 2f or between somewhere. So, you will be getting image between f and optic center. So, remember this. Clear? So, talking about the lens formula and magnification. The lens formula is expressed by 1 by v minus 1 by u is equal to 1 by f. I said you back there, mirror comes first, hence everything is positive. Lens comes second, so you get a minus here, that is 1 by v minus 1 by u is equal to 1 by f. And the magnification formula is positive, that is m is equals to height of image by height of object, v by u. There it used to be negative, but here it is positive. Moving forward, power of lens. So what is the power of lens? It's nothing but the degree of convergence or divergence of light rays. It's called as power. It is defined as the reciprocal of focal length. If they ask you to calculate the power, you can just reciprocal. You can take 1 by f and you'll get the value of power. And the important point over here is the focal length should be in meter. In the questions, normally we'll be dealing with centimeters, but if you want to convert it into power, it should be in the meter. Okay? And what's the SI unit of power? It is diopter. For a concave lens, power will be negative. For a convex lens, power will be positive. And remember, always the focal length is negative for concave. It may be lens or it may be mirror. Okay? So yeah, this was about today's video. And just within 20 minutes, we have done with this session. I hope this session helped you. If you want any addition, if you want to say any suggestion, you can just write down it in the comment section. I'll be going through your comments. Okay, so thank you so much for watching this video. I'm going to bring entire physics chapters just within 20-30 seconds. So let's do that, and very all the best for your exams. Thank you so much for watching this video. I hope you liked this video. If you have liked, just hit the like button, share the videos with your friends, and thank you so much for watching this video. Bye bye.